Okay, so this is 116 in your book. As you can see, we've got three forces applied at various points along this shaft, and we want to find a single resultant force and where it's located. So I'm just going to go ahead and kind of pencil in here that this force on the left has two components, x and y, and then of course the force on the right has different geometry and it has components. So the first thing we do to find the resultant force is we simply just sum the forces. Now, unlike equilibrium, we're not setting these equal to 0. We're just trying to find the resultant force. So when I sum the forces, I'm really going to sum up the x components and sum up the y components. So let's start first with summing up the x components. What do I get? Starting here at the left, what's the x component of that force? With this 3, 4, 5 triangle, the x component would be
500.
Yeah, it'll be 4/5. Let me go ahead and just pencil in that I'm going to say this is my x direction. So that'll be negative, and that'll be times 500 pounds. The second force has no x component. And then the right force has a positive component that is 5/13 of 260 pounds. So what is all that? Somebody compute that for me real quick. This one I can do, that one I can't.
300.
300? Oh yeah, this would be 20, 100. 100 plus, what's that? 400, should be 500? No, I forgot to subtract it, didn't I? Oh, these are both negative? This is positive, sorry. So it should be 300, you're right.
They got 300.
So let's sum all the forces in the y direction. And now everybody's going to contribute. So the first force is down, and that will be 3/5 of 500. Second force is just 200 pounds. And the last force is 12/13 of 260. That's minus 300. Plus 200 is 500. 640? I don't know, I'm guessing.
740?
740? What do you guys get? This is 300, that's 500, and this is 240, 740. Anybody do that right? I'm just kind of winging it. 740? You guys are really talkative today. You need to hold it down, okay? I can hardly think. So now what?
I do the resultant.
Yeah, so what is my resultant force?
Square root of.
So it would be in the x direction, it is 300, and that's I. And then it's minus 740 J, and that will have the units of pounds. Right?
Right.
Now the second point is, where is it located? So we'll sum the moments. They want it measured about B, which is over here on the end. So I'll sum the moments about B. So starting with this force here, broken down into its x and y components, what kind of moment does this force create about B? Well, the x component passes through B and creates no moment. So my y component, which would be 3/5 of 500, that's the force component. What's its perpendicular distance to B? 4 plus 2 plus 3. Looks like, what is that going to be? 9?
Would it not be negative?
Well, let's figure it out. So using the what kind of moment is that force creating about B?
Positive.
Positive. It's going to cause counterclockwise rotation about B. Everybody see that?
I don't.
Why not? Remember, well, I should do this. That's positive. So if you look at B and watch how this force is going to move around B as it rotates.
Okay.
It's going to rotate in this direction, right?
Mm-hmm.
So that's positive. Believe it or not, that's right-hand rule again. You put your fingers in the direction of the force and curl it about B. When the thumb hits you in the face, that's positive. Okay, what about this one? Again, that's going to be positive. It's 200 pounds. And what's the distance? 6 feet. We get to the last force. Again, it's going to create positive moment. The vertical component is 12/13 of 260. And what's its moment arm? 4 feet.
4.
So what is all that put together? No, I can't do that in my head. It'll take me too long. I can get one term. This is 2,700, right?
Yeah.
This is 1,800. I mean 1,200. This is I don't know what that is.
4860.
4,850
4860.
total.
Yes.
So 4,860, and that will be pound feet. So here's our equivalent force. So the distance from B will be what? It'll be this moment divided by that force. So I'll have 4,860 pound feet divided by the force, 740. What's that equal to? That's very close to 7.
6.56.
6.56? So I could now draw an equivalent system. I could come over here if I like and say, well, here's this weird thing that I'm doing here at A, and I've got this other kind of bearing block over here at B. So what I have now is an equivalent force of, let me see if we can get this to scale, about right here. So I've got a vertical component acting down of 740 pounds. I have a horizontal component acting along the shaft of 300 pounds. And that system is located at 6.56 feet from B. So I've turned this system into this system. It was very convenient that our X component, the way it was set up, created no additional moment about B. Any other questions about that one?